Example number 3. Now, number 3 is pretty complex. I now have a cannon. It's being shot off a cliff. I know my speed it's shot off, and I know it's at a 45-degree angle above the horizontal. That means I can set up the triangle below so that I'll be able to find my initial vertical and horizontal velocities, right, using sine and cos. It also tells me that it lands 140 meters from the base of the cliff. So this is 140 here, and I want to know my height of my cliff. So I'm going to do a bunch of stuff to do setup because I actually threw a bunch of stuff in here because I don't want you tripped up by it. I've done this on purpose to make this example have a few things in it. First thing we need to think about is the fact that we're dealing with kilometers per hour, but this is in meters. We also know acceleration due to gravity is meters per second squared. I don't want to mess with those. Instead, what I'm going to do is I'm going to change this. This is the easiest one to change. So I'm going to change 61.2 kilometers per hour into meters per second. Now, if you remember when we first started this course, we talked about the magic number of 3.6. So I need to decide, do I multiply or divide? And I know I can go really far in an hour, but can I go far in a second? No, I cannot, which means if I want to change kilometers per hour to meters per second, I'm going to divide. I need a smaller number for meters per second because I can't go very many meters in a second. If you've tried it, you'll know that, right? But I can go lots of kilometers in an hour because I have a lot of time. So I'm going to divide, and I get a very perfect 17.0. Now remember, this is a rounded number, but it's not a rounded number. It's an exact number. It's a perfect number. So I can keep as many digits as I want. I'm going to keep those 3 just for accuracy. So this is my velocity. But that's the velocity on the angle. So it's neither the vertical nor the horizontal velocity, right? I need both of those to start. And I've got a 45-degree angle. So vertical and horizontal information I'm going to kind of collect. So when I go to think about this, the first thing I'm going to do are my velocities. So vertically, V1 is equal to my vertical velocity, my starting velocity, which 45 degrees, it's across from the 45, so I will use the sine of 45 to find it. Don't forget to use the 17, right? Use your 17, not your 61.2 kilometers. It's really easy to forget and not use your converted. So I got the sine of 45 degrees there. And then I'm going to do the same but horizontally, and you'll notice the horizontal is cozy with the angle, which is why I'm going to use cos. Now, if you remember from previous examples, when I have 45 degrees, the sine and cos of 45 is the same number. So I actually only need to put this in my calculator once because I will get the same number. If you forget, it's not a big deal. You put it in twice, big deal. Who cares? I wouldn't even know it, right? Because I'm just going to look at your final answers. So I got 12.02. I'm keeping those extra digits for accuracy. So that's my V1. And then horizontally, my velocity is 12.02 as well. And it won't change horizontally, just vertically. Excellent. Okay, last bit of setup to do is that this 140 is obviously horizontal. So I'm going to put it over here, 140 meters. The other thing I can do is I know when this is true, I know it's going up when that's true, which means my acceleration due to gravity will be negative at that point. So when V1 is 12.02, my acceleration due to gravity is negative 9.8. So I don't really have enough information here, right? I don't know how high it goes. I don't know a bunch of stuff, but I know my horizontal. And horizontally, all I need to use is V equals D over T. So that's what we're going to do. We're going to find our time using the horizontal and then use that time over here to figure out the height of our cliff. We're going to stop there because I am running out of time on this video, and you can watch the second part to see the solution.